Alrighty, welcome to Module 5, Lesson 8, the difference between theoretical probability and estimated probabilities. Okay, so we're going to talk about those two types of probabilities. A bit different, of course, theoretical, as we've talked about in the past. This idea of theoretical probabilities are what should happen or what can be expected to happen. Okay, this idea of should or be expected to happen is theory. Is the theory. This whole idea of that should happen. Okay, you toss a coin, you should get one half of the times heads and one half of the time tails. Okay, that's theoretical probability. Now, estimated probabilities. We'll talk more about these as the lesson progresses. But those are probabilities that that are derived from experimentation. And those are things that we have been doing in class. Okay. Alrighty, so here we go. Estimated probabilities. All right. So, did you ever watch the beginning of a Super Bowl game? I think many of us, well, most people my age, of course, would say yes. I'm not sure about you guys. And most of you boys probably, and a good chunk of you girls have, but I'm sure there's a few of you out there that have never. Well, like any football game or pretty much any game, whether professional or not, a coin is tossed, okay, and that coin toss, and these coins are not just any kind of regular coin. When they have the Super Bowl, there's these gigantic coins, probably minted for that game only, kind of thing. But anyway, a coin is tossed to determine which team gets to, kick off or receive. Okay, you can make your choice if you win the toss. Okay, so whether or not you are a football fan, the toss of a fair coin is often used to make decisions between groups. Okay, this idea of a fair coin, that's really a very important point. Okay, is this idea of fair. Okay, there are unfair things. There are things called loaded dice, for example, where they are weighted in such a way that a certain number will come up more often. Okay, so so people are out there trying to rip you off whenever they can. But anyway, we're talking about a fair coin here. Okay. So, examples 1 through 9. Okay, it's going to take us all the way through this lesson. Why a coin? So, coins were discussed in previous lessons of this module. What is special about a coin? And we talked about that. In most cases, a coin has two different sides. Now, I am put the question mark there, and I put that question mark early in my strokes, my annotations. All these little drawings and writing and highlighting, they're all called annotations. Okay, but those I did that early. I figured out why they put in most cases now, but maybe I still don't understand. Any coin is going to have one side, two different sides. Okay, later on at the end of this lesson, you'll see they do something with pennies. Stacking pennies, things change. Okay, so you could have a head and a tails. Okay, that's what we call it. The sample space for tossing a coin is, of course, heads, tails, and that's displayed in parentheses, as you see there. If each outcome has an equal chance of occurring when a coin is tossed, of course, the probability of getting a heads is 1 over 2, or 0.5 or 50%. I'm not sure why they keep ignoring the percent here, but the probability of getting tails is also the same. And again, like we have mentioned before, we saw this last lesson. The sum of those probabilities will equal 1, which is 100% of all the possible outcomes. Okay, so the probabilities formed using the sample space and what we know about coins are called the theoretical probabilities. Okay, theoretical. All of this is based on theory. There are two sides. There's an equal chance of both happening. Therefore, the theoretical probability is 50-50, heads and tails, okay? But if we use observed relative frequencies, okay, and like running experiments like we have, that is another way to estimate the probabilities of heads or tails. Now, a relative frequency is the proportion derived from the number of observed outcomes of an event divided by the total number of outcomes. Now, of course, we've done this as well through our various experiments and lessons prior to this one. Now, you're going to recall from earlier lessons that a relative frequency can be expressed as, and we've expressed them as fractions, as decimals, or as percents. Okay, and again, like I said here, they really they've ignored the percents, and they'll ignore it for the rest of this lesson as well. Actually, we're talking in decimals throughout this lesson. Okay, is the estimate of a probability from this method close to theoretical probability? That's a question. It's a question if you want to answer. What do you think? One thing I do remember when we did our tiles. Actually, I think I wrote that down here. Yeah. So recall the colored tiles. Okay, the colored tiles. Remember when we picked those out of an envelope, all of the groups. What we noticed at the end is that just about everyone had very similar percentages or very similar probabilities for all four colors, as was the actual. Okay, so what did we have? I think we had 30. We had like 300, right? Like 300 and some, or 300 different outcomes. So that was a pretty big sample. All right. Anywho, yeah. So you can also estimate theoretical. You can estimate probability through trials, like the experiments we've done. Now, the following example investigates how relative frequencies can be used to estimate probabilities, okay, kind of testing the accuracy. And here is our assignment here. So Beth tosses a coin 10 times and records her results. And here are her results, okay? You can see, yeah, we got heads, heads, tails, heads, 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 tails, 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 heads. All right? So the total number of heads divided by the total number of tosses is the relative frequency of heads. Okay, we're going to be talking about heads only throughout this lesson. We are seeking to investigate relative frequency of heads. Okay, it is the proportion of the time that heads occurred on these tosses. All right. So the total number of tails divided by the total number of tosses is the relative frequency of tails, of course. Okay, but again, throughout this lesson, we're pretty heads crazy. All right. So here's Beth's example. So Beth started to compare the following. Started to complete the following table as a way to investigate the relative frequencies. So for each outcome, the total number of tosses increased. The total number of heads or tails observed so far depends on the outcome of the current toss. Okay, complete this table for the 10 tosses recorded above. Okay, so those tosses that Beth completed, all right, you need to go ahead and use those to fill this in. So let's just talk about what they did here. So here's toss number 1. It was a heads. Total number of heads so far. And again, we're fixated on heads. Okay, this is all about heads. Heads is 1. And then the relative frequency of heads so far. Okay, so far, all right, to the nearest hundredth. We're working in the hundredth place. Well, I mean, at this point, it's 1 over 1 or 1. Okay, because there was 1 toss, there was 1 heads. Tails, 0. I guess we aren't fixated on heads yet. We are doing tails as well. So here's tails. There's 0. Therefore, relative frequency of tails so far is 0. So this is not a reliable place to stop if we're going to go ahead and predict or estimate relative frequency or probability. 1 toss is not going to do the trick at all. Okay, and you can see what happens with 2. Second toss, another heads. Okay, 2 heads out of 2, still 100% or probability of 1. No probability of 0 for tails. And okay, so you can see how that moves. And hopefully you see, well, let's just go here. Now it adjusts a little bit. You can see toss 3 is the tails. Now there are heads. There's still 2 heads. But now this changes here. I can't keep it at 2/2. It's actually now 2 out of 3. So now it's changed. It's gone down from a probability of 1 down to a probability of 0.67. And now heads has actually gone up. Its relative frequency to 1 out of 3, which is 0.33 a probability, okay? Or a relative frequency is which we're really looking at right now. But you can see every time we go on the 4th toss, of course, you can remember that our denominator is going to be 4 here. Okay, so that denominator is going to continually change, as the numerator will change if, it needs to. Okay, so what I'm going to have you do is go ahead and pause and continue this, and just go ahead and finish up and complete this entire table, and come on back and we'll see how you did. Okay, so let's see how you did here. Okay, so another heads changes it. Now we have heads is 3 out of 4 right up to 0.75 and 0.25 on the tail side. Okay, and again you can see every time we go across here we have it's all equal to 1. Okay, so 1 right here, 1 plus 0 equals 1. 2 plus 0, and then 0, and then 2 divided by 2, of course, is 1. 2 out of 3, 2/3 and 1/3 also equals 1 whole. 0.75, 0.25 equals 1 whole. Okay, so you can see these are always going to, those 2 columns are always going to equal up to 1.0. All right? Okay, just wanted to add that. Let's just continue. Another heads brings that up to 0.8, and then tails down to 0.2. Another heads, wow, so you can see as you're throwing the heads, the relative frequency is going up, okay, and you can see that tails is going down. And now a tails came on board, and you can see it change again. And then we have tails again, and it's going to change it even more. So you can see how these are getting more and more even. Another tails is going to get them nearly even, and then actually another heads kind of pulls them away. So right here at the end of 10 trials, and again, or 10 tosses, which is not much, with a theoretical probability of 50-50, our estimated probability here, or relative frequency, is actually 60-40 on the head side. Okay, a little bit different than the theoretical. So down here, number 2, what is the sum of the relative frequencies of heads and the relative frequency of tails? Okay, that's what we did up here, and that's always, of course, 1.0, and you can see that continually happen. Okay, 0.6, 0.4, of course, is 1, and all the rest are the same. Okay. All right, now we're going to do a little bit of graphing. Okay, so Beth's results can also be displayed using a graph, and they are very often, graphs are used over and over and over again in statistics. Okay, graphs, again, they are this graphic way to display data. Okay, they make trends pretty obvious. If there's a downward trend, or if there's an upward trend, or there's a leveling trend, they make it much more obvious than looking at just numbers, straight numbers, but actually looking at a graphic depiction of those numbers helps, and can also mislead, because these statistics, especially graphs, can often mislead people who look at them. Okay, but anyway, what we're going to do here is from the table above, okay, using all the results that we filled in just now from Beth's 10 tosses, we're going to complete the graph below using the values of relative frequency of heads so far. And you can see what they've done a couple for you right here, where they've already plotted where the first toss, and then we had heads relative frequency was 1.0. After the second toss, it was still 1.0 because it was 2 out of 2. After the third toss, now because it was a tails, it was down to what, 0.6 something 7, was it 6.7? I think something like that. Anyway, you go ahead and use those numbers, use that data, and go ahead and plot your points, and then connect your dots with a using a ruler, preferably. Make it look nice, even though I might not look at it. I think you should always do your best work. So go ahead, I'm going to pause, and you go ahead and complete the graph. Okay, so let's see how you did. I'm going to go ahead and hit this button. I think every point is going to get plotted. No, one at a time. Okay, so there's that one. On the fourth toss, what happened? Again, another heads. And you can tell, I mean, I don't even have to tell you what's happening. If I see that those dots rising, I know that heads are being tossed, okay? Because the relative frequency is going up over here, and you can see that, okay? So next one, whoop, must be a tails. Another tails. Another tails. Oh, and finish off with the heads, okay? And then if we go ahead and draw our line, our graph is going to look something like that, okay? So if your graph looks something like that, that is good, okay, because that means you have plotted your data correctly, okay? And again, graphs are something you're going to see more and more often as you move through algebra, so get used to them and become friends with them, all right? Okay, so I mean, if you look at this graph, you can see a leveling off, you know, of the relative frequency. It all was pretty high right here, relative frequency for heads. Took a big drop right here, and that just took one toss to bring it down that far. But then, as you can see, kind of leveling off right there. Okay, so as we move on here, number 4, now Beth continued to continued tossing coins and recording the results for a total of 40 tosses, okay? So 30 more times. So here are the results for her next 30 tosses, okay? There they are, all right? And she's recorded all those for you, all right? And you notice as the number of tosses increases, the relative frequency of heads changes, okay? And we saw that on our graph already, okay? You can see it change. In that case, it leveled off. So what you're going to do right now is you're going to go ahead and complete the following table for the 40 coin tosses, okay? And you can see what they have done here is they just want the just certain benchmark points, okay? You have a 1 toss, at 5 tosses, at 10 tosses, and those are from the results prior, okay, the prior table. And then all of these here can be found above, 15, 20, 25, 30, 35, 40. Okay, all of these can be found in the table above. So for example, if you want 15, okay, after 15 tosses, you need to count up how many heads there were, okay, at that point. So you gotta, you have to count and just continue. All right, so it's not too complicated. I think I think you can figure it out. Go ahead and write the total number of heads so far at that point, okay, after 1 toss, after 5, after 10, after 15, 20, 25, 30, 35, 40, and then go ahead and calculate the relative frequency of heads so far. Okay, so for example, just to let you know, at the 40th toss, of course, your the number you're going to use as your denominator to calculate your relative frequency, of course, is going to be 40. Okay? So go ahead and do that and come on back and we'll check. Okay, let's go ahead and check what happened here. All right? And, I guess I did this really fast. Okay, I thought I had paused, but I didn't. Here are all of my answers. Okay, and we can check them. Check yours against these. All right, and again, these are a couple things we saw already. Was the 1 After one toss, there was one head, and that's a relative frequency of 1.0 or 1.00, so we're going to the nearest hundredth, 1.00. At 5, we had 4, still a very high relative frequency, 0.80. At 6, you could see now we had some, we're going down, 0.60 relative frequency is dropping, and at the 15th, toss, it fell even more. After the 20th toss, it actually went up a bit. I think there were a couple up to the 20th toss. Look, we had quite a few heads up here. Look at that, we had 3 between 15 and 20, which brought that relative frequency up, but not all that much, okay, because we're talking about 20 tosses now. After the 25th toss, 13 brought it down a bit. After the 30th toss, it went down to 0.47. After the 35th, up a little bit. After the 40th, down a teeny bit. And you can see these moves are actually quite small here in percentage terms. Okay, we're talking about hundredths of only talking in hundredths here, not in tenths any longer. As you get more and more tosses, okay, it becomes harder and harder to change that relative frequency. And if you look at it, it kind of makes sense if you're tossing a coin. Okay, all of these here, actually, all the way from after 15 all the way down to after 40, you're really close, very close to 0.50 or 50%. Okay, all right, which seems to make very good sense, tossing a coin. Okay, so from the table above, again, getting used to using graphs to graphically depict your data. You're going to complete this graph below using the relative frequency of heads so far for the total number of tosses at 1, 5, 10, 15, 20, 25, 30, 35, and 40 tosses. Okay, so go ahead and complete that graph. Let's see what you can do. We're not going to start you off. Just see what you can do yourself. Go ahead, good luck, have fun, and just see if you notice any trends, and if you can see those trends actually more clearly when you create a graph. Okay, so let's start plotting these points. There's after our first toss, remember we're at 1.0. After 5 tosses, we're at 0.8. 10 tosses, we were at 0.6 or thereabouts. 15 tosses, we were 0.55 or something like that. I don't know exactly. I think at 20 tosses went up to like 0.56, and down a little bit after 25, and you can really see right here what is happening. Very clear. You can see after a very kind of a skewed first results. Of course, you throw one head at a 100%. Okay, it starts up there, but you can see very clearly as we draw our line how it starts to level off. And if you notice where it is leveling off, right at that 50% mark. Okay, you can really see that very clearly. And this is after only 40 coin tosses. Okay, so and again, this is all hypothetical data by a girl named hypothetical person named Beth. All right. Anyway, there you go. So they asked the question here: what do you notice about the changes in relative frequency of the number of heads so far as the number of tosses increases? You could write whatever you want to write in there. I think you have a good idea. We talked about it leveling off. Okay, as the number increases, the relative frequency of heads tends to level off. And again, we're not sure what this would look like. It could be it could start to go up to 100. Who knows? I mean, it's all chance anyway. I mean, it could tend to maybe rise and then fall again. Who knows? Okay, most likely not. Okay, again, because it's very difficult. You'd have to throw like maybe 10 heads in a row to really get it to start moving really sharply upwards. Okay. All right. So if you tossed the coin 100 times, What do you think the relative frequency of heads would be? Explain your answer. Well, you could think about that for a little bit. Actually, why don't you think about it? Give me an answer. Write it down. All right, and number 8 as well. Okay, and come back and we can discuss it. But I'd like you to actually get used to writing something down, okay, a little explanation, because they want you to explain your answers in both of these scenarios here, okay? And again, number 8 says, based on the graph and relative frequencies, what would you estimate the probability of getting a heads to be? Okay, and explain your answer, all right? So yeah, go ahead and do that, jot some things down, and I'll come back and with something of my own. Okay, so as far as number 7, here's what I wrote. I wrote that I would, I would think about 0.50 thereabouts. And because after 40 trials, it was already basing there, so I think that that will continue. That trend will continue. I would just estimate 0.50, and I'd be pretty confident I would be pretty close to being correct. Okay, so in terms of looking at those graphs and the relative frequencies, what would I estimate the probability of getting a heads to be? Again, I said 0.50, as the graph showed a leveling off or basing at the 0.50 relative frequency level. Okay, so I would believe that that would continue. I'm sure. Okay. So the value you gave, okay, is at the bottom in yellow. The value you gave in exercise 8 is an estimate of the theoretical probability. Okay, so number 8 was an estimate of the theoretical probability, and it is called an experimental or estimated probability. Okay, so there is our estimated probability right here. Okay, because it is an estimate. Oops, sorry. It is an estimate of the theoretical probability. Okay, right there. That's what I estimated, okay, based on my experimental or estimated trials, my trials there, okay. All right, so it's not theoretical anymore. It's actually based on experiment or based on observation, okay. And it's pretty darn close to the theoretical probability of flipping a head. Okay, so some history of those observing long-run frequencies. Okay, this is really fun. So in let's see, in the 1700s. Okay, there's this French naturalist, Count de Buffon. Okay, and the story tells that he actually tossed a coin. In particular, the tossing of a coin. Okay, yes, I'm observing long-run frequencies, tossing of a coin. Well, this guy, this Count Buffon, well, he tossed it 4,040 times. I don't know why 4,040. The result, 2,048 heads, and his probability there, or his relative frequency, was 0.5069. You can see how darn close that is to 50% or 0.50. Around 1900, there was an English statistician named Karl Pearson, and he tossed a coin 24,000 times, and he got 12,012 heads, and that is even closer to 0.50 or 50%. All right, and then actually these are kind of out of order because this next one is a 10,000 toss trial, and that was actually during World War II, a South African mathematician, John Carrick. He was imprisoned by the Germans, and he tossed a coin 10,000 times. I guess in prison it might be a thing you might have time to do, and he got 5,067 heads for a relative frequency of 0.5067. But you can see right here, this longest trial, the 24,000 trial, actually yielded the relative frequency closest to a pure 50%. Okay, and you can see that 24,000, 12,000 out of 24,000. pretty darn close to that theoretical probability, which might lend credence or lend some support to this idea of increased trials, longer the run, longer your observation of these happenings or outcomes, the closer and closer you'll move towards that theoretical probability. Okay. All right, so here exercises 1 through 8, more Beth stuff. Okay, we're going to continue on with Beth, but she does something a little bit different with her pennies. Okay, now she gets 9 more pennies, so she has a total of 10. She securely tapes them all together to form a small stack. And that stack, the top penny of her stack showed heads, and the bottom penny showed tails. All right, and that probably looked a little, well, hold on a second, I have a little picture of a stack of pennies. But anyway, if Beth tosses the stack, what outcomes could she observe? Okay, we know 1 penny is going to get you a heads and a tails. Okay, 2 different outcomes. Here is that stack of pennies, let's say. Okay, a stack of 10 pennies. Can you imagine right now what those possibilities would be? So why don't you go ahead and think about it a bit, or if you've thought about it already, if you want to pause, go ahead and pause and think about it a bit, and come on back when you have an idea of what you think these outcomes she could observe. Are they the same, a heads and a tails, or is there some other outcome that's possible? Okay, well, if you thought about it like I did, there'd be a new outcome would arise, as the stack could land on its side. Okay, could land on its side. All right. So now Beth, she wanted. Okay, so now we have a our sample here set here as heads, tails, or side. Okay, heads, tails, or side. Okay, we can put that in parentheses actually. All right. Yeah, so Beth wanted to determine the probability of getting a heads when she tosses the stack. Do you think the probability is the same as the probability of getting heads with just 1 coin? Okay, and explain your answer. All right. Well, if we have this universe of possibilities here as now heads, tails, and side, well, it's going to change quite a bit. Okay, it's going to change a bit. The probability of getting a heads, of course, would change, as there are now 3 possible outcomes. Okay, so what would that probability be? Of course, you would know it would be 1 out of 3. Okay, or 0.33 would be that probability. Okay. All right, so now I'm going to enlist you to do something, and please do it. It was a lot of fun for me. I had a lot of fun with this activity. We all have some pennies stashed somewhere. We have a little change jar, which I've noticed is actually getting dipped into more and more these days. My son out there buying himself some drinks at the Shell down the street, or a slushy or something. Anyway. Yeah, so go ahead. So you're going to make a sturdy stack of 10 pennies, in which one end of the stack has a penny showing heads and the other end tails. Okay, so you're going to stack these pennies together, 10 of them. Just make sure one is showing heads on the top or whatever, and then one on the other side, other end, is showing tails. Okay, so make sure those pennies are excuse me, are stacked or taped securely. Okay, or you may have a mess when you toss the stack. Okay, toss the stack to observe the possible outcomes, and again, they're going to ask some questions here. What is the sample space for tossing the stack of 10 pennies taped together? Well, that would be this here, this sample space right here, or HTS, heads, tails, or side. Okay, and do you think the probability of each outcome of the sample space is equal? Explain your answer. Do you think those are equal, an equal chance of heads, tails, or sides? And I'll ask you to pause right now, think about it, or actually go ahead and make your stack of pennies and come on back. Pause, make your stack, come on back and answer this question, and then we'll start. Okay, so here's what I thought. Well, here's my stack of pennies, as you can see right there. Okay, my stack of 10 pennies. See, it's showing heads on top. I don't know if you can actually see that, but the tails is showing on the bottom. Again, like I said, it was I had a lot of fun. Anyway, the idea of do you think the probability of each outcome of the sample space is equal? I said no, I didn't think so. Just because I thought there would be a tendency of the side. I was thinking about the cup. I don't know if you remember we tossed that cup, and boy oh boy, ended up on its side more often than on its head or its tail, okay, or top or bottom. So I was thinking about that, and I thought the frequency, the relative frequency, or the probability of the side outcome would be greater. Okay. Anyway, I went ahead and flipped it 10 times. Okay, I tossed it 10 times, and here's what I got. Okay, you can see a lot of sides, and I was thinking, wow, hey man, you're really justified in your prediction. So I had a 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see I flipped it 10 times to make my prediction, and I could see the tendency of getting the sides as I thought it would be greater seemed to be the case. Okay, as you can see, there were 1, 2, 3, 4, 5, 6. Oh, sorry, 7 out of the 10 were sides, and then 3 out of the 10 were heads, and I didn't flip a tail. Okay, that entire time. All right, but things did change a bit. Okay, and here, record the results of 10 tosses. All right, so I went ahead and did that. Okay, I did my 10 tosses, those 10 first tosses. All right, and I would like you to go ahead and do the same. So go ahead, if you haven't yet, go ahead and flip your stack 10 times. Be careful. I use clear tape. I used a clear Scotch tape. There was a point where it started to rip on the side, so I went and just patched it up a little bit because they will fall apart. All right, so go ahead and do that. Flip it 10 times, record your results, and then go ahead and record your relative frequency of your heads so far. So each separate time, based on, for example, here, if you see my result here was side, relative frequency of heads right here is 0.00, okay, because I hadn't yet flipped a heads, okay. The same here, 0.00, all right, and so on, okay? So you can see, because that's going to be, this was 0 out of 1, this was 0 out of 2, and you can see what's happening over here. This is 1 out of 3, and of course I think you have an idea of what that relative frequency as a decimal is. So go ahead and do that. Flip the coin 10 times, record your results, and then record the relative frequency of heads so far on the on below each one. Okay, go ahead and do that, and come on back. Okay, so I'm just going to show you mine, and then of course yours is different. I hope you did it yourself because it's just a lot more fun to do. And like I said, flipping that stack was a blast. Anyway, if we go ahead and look at all of these, you can see that relative frequency of heads so far go through lots and lots of changes for me. Again, yours are not going to match mine necessarily. If they did, I'd be quite amazed. But you can see how they, it starts real low right here at 0, 0 up to 33, down to 25. Oh, down again to 20, down again to 17, down again to, I'm talking in percents now, 14%. 12.5%, but now I move up. It only takes, look at that. Now that's quite a drastic. Now we're only talking about, the ninth toss right here. So you can see it goes from 0.125, 12.5% up to 22%, a whole 10% difference in one flip, and then again up another 8%. So it ends up that heads probability or heads relative frequency was 0.30, okay, which is would be 1 out of 3, just about, okay? But this next question, and again, these are all going to be different for you, okay? So different for you. So a lot of these answers are going to be different for all of us, okay? Just you can base all of your work on what I'm doing, okay? Yeah, so anyway, based on the value of the relative frequency of heads so far, okay, what would you estimate the probability of getting heads to be? Now, I would not think that heads, I still think side, because look at all these sides, okay? All these sides, there's a lot of them, okay? And I don't really think that heads is going to maintain that 0.30, okay? I'm going to, I want to say in the 20s maybe, okay? I'm going to say 0.2, I'm thinking 2, 4, 5, I don't know, maybe 5, okay? 0.25 would be my estimate, all right? Okay, let's see how close I come here. All right, now we're going to go ahead and toss the stack of pennies another 20 times. Okay, and then we're going to complete that table, the following table. Okay, just toss and record, toss and record, toss and record, all the way until you get up to 30 tosses. Go ahead and do number 6. Go ahead and summarize the relative frequency of heads so far by completing the table at all those different points. 1 toss, 5, 10, 15, 20, 25, 30. Okay, exactly the same as we did with all of those pre-plugged in results from Beth early on in the lesson. Okay, we're doing actually pretty much the same exact thing. Okay, and hopefully you guys are doing this yourself, but if not, you could watch my results. Okay, so I'm going to pause. You go ahead and do that, and come on back. Okay, so let's take a look at my results here. And again, your results will be different. If they're not and they're exactly the same, we need to buy a lottery ticket together, okay? So here we go. Here are my tosses. Heads, tails, side, heads, heads, side, 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 tails, heads, 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 tails, tails, side, side, heads, side, tail, tail, tails. All right, you can see very, very different looking than the first go around, the first 10. There's no string of 10 here that looks at all like the first string of 10 I flipped, okay? So if I go ahead and I'm going to go ahead and summarize down here. At 1 was 0.00. We saw that already. We also saw at 5 it had gone up to 0.20, okay, because it was 1 out of 5. Then I had 3 out of 10 at the end, remember, and I had 30 or 0.30 or 30% was my relative frequency. It even went up even further. You can see that the 5 here, those next 5 I flipped. Look at 3 out of those 5 heads. That gave me a big boost, another 10% boost up to 40%. After 20, now another 5 flips, and I only got 1 more, and that brought me down 5% down to 0.35. 9 heads out of 25 gets me a relative frequency of 0.36. And I'm a little bit nervous now because I didn't think I could maintain that 30% rate. But as you'll notice, look at that. After 30 tosses and 10 heads means I ended up exactly back where I ended up after 10. Something I would not have predicted, but again, this is all a game of chance when you're flipping coins, and especially when you're flipping coins that aren't necessarily fair, like the stack. Alrighty, so I don't know how yours came out. I hope it was fun. I'm not sure. I'd really love to know what kind of relative frequency you guys ended up with. It would be quite interesting, I think. All right, so but now we're going to continue. So based on the relative frequency of those 30 tosses that you did, again, you're thinking about yourself, what is your estimate of the probability of getting heads? Okay, can you compare this estimate to a theoretical probability like you did in your first example? So think about this. Can you compare with theoretical probability, okay, like we did with the single coin flipping, okay? Well, I'm going to, oopsie daisy, I guess I didn't, hold on, all right, sorry. Yeah, I didn't do any annotation, any other annotation. But anyway, yeah, well, based on these relative frequencies of my 30 tosses, my estimates of probability of getting heads, again, I ended up with 30%, or that 0.30 after the 30 tosses. I still don't feel really confident in that. I still want to say a little bit less, but boy, I tell you, the way it's going, another hunch. That's another. If we were going to do it, I don't know how many more times, 10 or 20 or 30 and 40 and 100, whatever. I'm not sure. I still want to say 0.25. I think there's going to be a big string of side flips in there somewhere into the distance, but that's going to be a pretty hefty chore to actually go down 5 percentage points, or 5/100ths in the decimal, going forward. Okay, that's pretty heavy. You have to get a lot of other flips in a row. Okay, now as far as that second part there is, can you compare this estimate to the theoretical probability like we did in the first example? You really couldn't, because we now have that stack of coins, which is pretty much still, even though I did get 0.30 heads, or 30% heads, it's still weighted a little bit on the side, because if I went ahead and I did check out my relative frequency of the side toss, and it was still upwards of it was over 50%. Okay, so side was still pretty dominant. I think it was actually, it was actually 50%. I think, because heads was about 0.30, my tails was about 0.20, and then my side was 0.50. So I still think this is definitely not going to be subject to any kind of theoretical probability estimate, okay? Because it is not fair in that sense, okay? All right. So the rest of this asks us to, and again, I'm going to have you just skip 8, because what's going to happen in your problem sets, you're going to see this again. But if you want to now, before or right after we close the lesson, just to create another stack of pennies, and just consider, a stack of 5, 15, 20 taped together, okay? And go ahead and toss and get your results. Maybe you can do, a stack of 5 here, a stack of 15, a stack of 20, and you can compare it to your other results. Or you can just do, 30 flips of one of these scenarios and see how it compares to the one you just did. Okay, that's up to you. Like I said, your problem set is going to include some of those things, activities like that as well. Okay, so again, our lesson summary. The big idea here is observing the long-run relative frequency of an event from a chance experiment, or the proportion of an event derived from a long sequence of observations, okay, same thing, approximates the theoretical probability of the event, okay? And again, if this was all fair, okay, and that's a real big point, a real important point, okay, it has to be fair. A coin is fair pretty much. The stack was not. But anyway, we can approximate a theoretical probability with a long run of trials, okay, a long run. And then next here, after a long sequence of observations, the observed relative frequencies get close to the probability of the event occurring, okay, so they'll get, this relative frequency will get very close to the theoretical probability. Probably never exactly reach it or maintain it, but it will get close. And we saw that happen, both times with that, with those graphs, Beth's first graphs. Okay. All right. When it is not possible to compute the theoretical probabilities of a chance experiment, then the long-run relative frequencies, or the proportion of events derived from a long sequence of observations, can be used to estimate probabilities. Okay, so if we have a situation where it's not necessarily not necessarily fair, and it makes it impossible to compute theoretical probabilities, we could use a long sequence of events to or observations to come up with an estimate, an estimated probability. Okay. Anyway, yeah, went a little longer this time, 50 minutes, still not so bad. I hope you enjoyed this. I hope you have great success on your problem set, and see you next time around.